Good afternoon, everybody, and welcome to MOS Live for our virtual planetarium exploring space today. My name is Karen. I'm one of the many educators at the Museum of Science. Today, I'll be acting as your moderator. And what that means is I will be keeping an eye out for all of your comments, your observations, your questions, and passing them along to our planetarium educators today. Now, if you do want to ask a question here on Zoom, you can use the Q&A box, just type it in and it'll come right to me and I can pass it along. If you are tuning in today via Facebook or YouTube Live, we're so appreciative that you are here and watching us, but unfortunately we cannot field comments or questions from those platforms. And lastly, if you do need closed captioning, you can click the CC button and choose Show Subtitles. So with that, I want to invite our planetarium staff to come on and introduce themselves, and we'll get started.
Hello, everybody. My name is Talia. I use she, her pronouns, and I am going to be your guide as we explore some space today.
Hi, everyone. My name's Katie. My pronouns are she and her, and today I will be flying you through space.
And today we're going to be focusing on one of my favorite things to talk about, exoplanets. Exoplanets are planets orbiting stars that are not the sun. So they are planets in other solar systems. We discovered the very first planets outside of our solar system by accident back in 1992. And those planets were a bit strange because they were not orbiting a live star. They were orbiting what's called a neutron star or pulsar, which is something that gets left behind after a big star runs out of fuel. So it was a little strange because it wasn't really a solar system like ours. It didn't have a live star at the center of it. We found the first stars or first planets orbiting an actual live star, again by accident, in 1995. So as you know, astronomy goes, this is actually a relatively recent field, but since 1995, the number of known exoplanets has really just skyrocketed. And Katie can show us a graph which sort of really displays exactly how fast the numbers jumped once we started finding them. So you don't have to worry too much about the colors here. The colors indicate how we find them. There's a couple of different ways to find them, and I'm going to be going into a couple of those. But you can see how rapidly this field has been growing over the last couple of decades as the numbers just go up and up and up and up. And the two colors that you see most here are red and green. So the two methods that we use most often to find these exoplanets are what we call the radial velocity method and the transit method. So I'm going to explain to you what those are, starting with radial velocity. And what that means is both of these are not dependent on finding the planet itself. We find them by looking at the effects that they have on their star. So we're going to start by taking a look at what exactly is going on when we use the radial velocity method. So what that means is, of course, we all know that a star's gravity holds onto a planet, right? The planet orbits the star because of the star's gravity, but the planet's gravity pulls on the star as well. It's a much, much, much tinier effect that is very much exaggerated in this video that you're seeing here. The star isn't so much orbiting as it's just wobbling slightly, but that wobble actually changes the star's light as we see it from Earth. It causes it to actually shift a little towards the red end of light or a little towards the blue end of light, depending on which direction the star is going. And it's a good indicator that there's something pulling on that star, which doesn't have to be a planet, but it certainly could be. So a lot of the first planets that we discovered were found using this method. But this method is really good because it depends on a planet having a gravitational effect on its star. It's really best for finding really massive planets that are pretty close to their stars, what we call hot Jupiters. It's a type of planet we don't have in our solar system. And at first, most of the planets we discovered were hot Jupiters because these are the ones that make their star wiggle the most, and they were the easiest to spot. But of course, if you're looking at planets in other solar systems, what you really want to find isn't a hot Jupiter. You want to find something that might be a little bit more like Earth. The radial velocity method really, especially at first, was not great at finding things like that. But there's another method that is much better at finding smaller planets, and that is the transit method. Now, this method works. It's a little bit similar to an eclipse. What happens is if the orbit of the planet is oriented so that the planet will go between the star and Earth, it's going to make the starlight dim a little bit because it's going to be blocking some of the light. Like I said, it's a little bit like an eclipse. And again, it depends on orientation. If you're looking at it from, say, this perspective, you never see the star's light being blocked. But if the system is oriented so that the star does, or so that the planet does go between the star and Earth, you're going to see that light block. And that's a good indication that something is orbiting that star. And this is a way that we have found a lot of exoplanets, and it's a way we found a lot of the smaller end of exoplanets. And if we can actually just jump back to that graph that we saw before, I want you to notice something. You'll notice that while the number of planets discovered by radial velocity sort of has just been a slow, steady increase since 1995, the number of planets discovered by transits really starts to take off in 2009 and then jumps dramatically. So 2009, 2008, 2009 is where you really start to begin to see those transit planets discovered, and then they jump progressively year by year by year, which means something must have happened in 2009 that changed the game. And it happens to be that was the year one of my favorite space missions was launched. It was a space telescope. It's called the Kepler Space Telescope. And we can actually show you what that would look like. So here's a model of what Kepler looked like, still looks like. It's named for the astronomer Johannes Kepler, who was very active in the late 15 and early 1600s. And like I said, it was launched in 2009. And this really changed the game. If you look at one of the exoplanet databases like the Exoplanet Encyclopedia, something like 70% of its entries are things that were discovered by Kepler. This program, by the way, is a program called NASA's EYES, specifically the one that is eyes on exoplanets. And all of these bright star-like things you see in the background, these are known exoplanets, not necessarily Kepler ones, but just confirmed exoplanets. And the funny thing is that Kepler managed to change the exoplanet hunting game, even though it's not a terribly big telescope. So for instance, we can actually, one of the fun things about this program is we can compare its size. So let's go ahead and compare it to a school bus, which is, you'll notice a school bus is much bigger than Kepler. Kepler is significantly smaller than the school bus. If you were to compare what's probably the most famous space telescope, which is Hubble, Hubble is longer than the school bus. It's much bigger. And if you were to compare this to, say, the next generation of big space telescopes, which would be like the James Webb Space Telescope, that's often compared in size to a tennis court. So Kepler is not a very large telescope. In fact, comparing it with a school bus maybe isn't the best comparison. This is, you can actually just easily compare it to the size to a human. So there's a human next to it. It's you know, a couple of humans tall. And its mirror is very small for such a big game-changing telescope. It's only about 3 feet across. And if you've tuned into any of our programs in the past, you probably know that it's that size of the mirror is what makes a telescope really, really powerful or not. And Kepler doesn't have a very big mirror, only about 3 feet across. It's about 1/3 the size of Hubble. It's way smaller than a lot of the big telescopes we have on Earth. So what is it about Kepler that made it such a game changer? I'm going to go ahead and ask you that question. It's kind of a tricky answer, so I won't be surprised if you want to answer question marks as the answer. But I'd like you to think about it. What could be different about this telescope that made it such a game changer over things like Hubble, over many of the huge ground-based telescopes that we have? Think about it. If you can think of an answer or a guess, go ahead and put it in the Q&A. And if you're really not sure at all, go ahead and put question marks, because one of the best things you can do in science is know what you don't know and be willing to admit it. So question marks are a great answer.
My guess is that maybe it had such a specific purpose, but now we're starting to get some other answers in. We got two question marks. Somebody speculates, is it looking at infrared or X-rays instead of like visible light? More question marks, some question marks with exclamation points, question marks with why. I think people definitely are, more question marks, are looking for more information, Talia.
Fair enough, because it does have to do a little bit with the fact that this is a telescope that was specifically designed to look for planets, unlike, say, Hubble or any of those other ground-based telescopes. And that means that its mission got to be designed a little bit differently. For one thing, Hubble and all those telescopes on Earth, they need to deal with Earth itself, because Hubble's in a low Earth orbit. The ground-based observatories are on Earth. Kepler doesn't have to worry about Earth because it's not orbiting the Earth. It's actually trailing behind Earth. It's in an orbit around the sun. It's trailing behind Earth, which means it doesn't have to worry about where Earth is. Earth is never blocking a bunch of its sky. And because this was its only mission, it could do something that none of the rest of those telescopes could. It could stare at one single patch of space for years and years at a time. And this is what Kepler did. It didn't look all over the sky. It stared at this one patch of space.
It's like a boring existence, Talia.
Well, but this is how you find planets, because think about it. Let's say you were on a distant planet and you were looking towards the sun, and Earth was in the right orientation to block part of the sun's light. How often would you see Earth blocking the sun's light from your perspective on your distant planet? Think about that for a moment. Go ahead.
Very true.
Enter an answer in the Q&A if you can think of it. You can always put question marks. But if you were on a distant planet looking towards our solar system, how frequently would you see Earth blocking light from the sun?
Once a year, question mark, Earth year, question mark, every 365 days. My guess is that it would block the light from our sun for a couple of days, couple of weeks, depending on what distant planet you were on.
But you guys are getting that right. It would do it once a year, which means if you weren't staring at it, you'd be lucky to see it. And this is what Kepler did. It stared at this one patch of space for many, many years, and it looked for transits. And it wasn't just trying to find one, because one blocking of the light, that could be a planet. It also could be something like a sunspot. There's other things that could be. But if it saw it twice, then that was a pretty good bet that you were looking at a planet. And that required being really patient and just staring at this one patch of space. So Kepler stared at this one patch of sky from 2009 to 2013. And I know from here it looks like it's sort of flat, but if we zoom out and take sort of a different perspective of it, you'll be able to see it's actually a cone. So that cone with all the yellow in it, that is the Kepler, what we call the Kepler field. And it extends a very long distance out into space. There's thousands of planets in that cone that Kepler was able to discover, some of which have been confirmed, some of which have not. They're still considered Kepler candidates because it takes more than just Kepler to find them. You do need a second observation to confirm them. But look how many planets it discovered in that one little patch of space, because this was something we did not know before we launched Kepler. How common are exoplanets? So this was one of the things Kepler needed to find out. By looking at this one patch of space, if it only found a few planets in that space, that would tell us that planets were pretty rare. But you can see it didn't. It found a ton of planets in that space. And this is one of the main reasons we now believe planets are as common as stars, that there are as many planets in our galaxy as there are stars. So that is the main Kepler field. Now you might notice all of what Katie has filtered it out so that all of what we're looking at here are just Kepler planets, Kepler discoveries. And you might notice it's not just that main cone. There's all these other ones in these sort of spokes around it. And this has to do with the fact that, well, Kepler was only designed to last for 3 years. It was only supposed to work for 3 years. It launched in 2009. They were hoping it would work through 2012. It was able to observe through towards the end of 2013, which was great. They got more data out of it than they were expecting. But then in 2013, one of its reaction wheels broke. And this was very important. These reaction wheels are how some telescopes keep themselves pointed and stable. Hubble has them. And it was how Kepler kept itself pointing in a very stable position at that one patch of space. Once that reaction wheel broke, it couldn't point in that one spot anymore. It was going to always do a slow tumble. So, well, that's it, right? That's the end of the mission? Well, no. NASA engineers are pretty clever about stuff like this, and they figured out a way that Kepler could continue to discover exoplanets, maybe just not quite with the same depth that it was able to before, and something they called the K2 mission. And that's what all those spokes were. Kepler started a very slow tumble because its wheel was broken. And that meant it wasn't just staring at one patch of space, but it was sort of looking in the same direction for about 3 months at a time before its field of view would shift. And so these spokes are those patches of sky that Kepler stared at for not 4 years at a time, but 3 months at a time, which still led, as you can see, to a whole bunch of discoveries. And we still haven't finished going through the Kepler data, honestly. There's still discoveries being made in Kepler data because Kepler itself is no longer with us, I'm afraid. It continued the K2 mission from 2014 to 2018. So 9 years after it originally launched for its 3-year mission, that is when Kepler ran out of fuel. So in 2018, it was shut down for the last time. Actually on the anniversary of the death of Johannes Kepler, for which it was named. The 388th anniversary of his death was the day they shut down Kepler. It was a sad day for me because I really liked this telescope. And I've been talking for a while. Before we keep going, Karen, are there any questions I should try and answer?
There are several. I think this is a really poignant one. Christian, Juliet, and Emily ask, how many cycles did Kepler have to detect the dimming of light before the exoplanet existence was confirmed?
So Kepler would pick out an object of something would become a Kepler object of interest after one dimming. They looked at it and said, yeah, that looks like the pattern of a planet dimming a star, then it became a Kepler candidate. So there are a lot of things out there, thousands of things that are still considered candidates from Kepler, because they then have to be followed up by an observation from a ground-based telescope, at which point it becomes a Kepler planet. And there are a lot of planets in our exoplanet catalogs that have the word Kepler in front of them because Kepler is the thing that discovered them.
Cool. And Shelley and Alex want to know, is Kepler still floating in space?
It is. All we did was shut it down. So we didn't move it. It's still trailing behind Earth somewhere, but it's never coming home. We never planned to bring it home.
A one-way trip. And this question came in a little bit earlier. I don't know if it was in reference to something you were talking about, but has the Terrestrial Planet Finder been launched yet?
Terrestrial Planet Finder, I'm wondering if that is the old name for the satellite I'm going to talk about in a little bit. Certainly nothing named Terrestrial Planet Finder has been launched, but I think it changed its name, and I'm going to talk about it before.
Well, good, because somebody else asked, are there plans for a new Kepler, which I'm guessing you are going to talk about.
Well, we'll talk about it. Before we do, though, I want to highlight a few of the particularly notable discoveries that Kepler made. So if we could spotlight Katie's feed again. For instance, I always like this one, the Kepler 16 system. This is one that was confirmed to be a planet. So it has the word, it's called Kepler 16 is the name of the star, or rather stars. And this planet is Kepler 16b. And I say stars because this was the first time we ever discovered a planet that was orbiting 2 stars. We used to think that it couldn't really happen, that the planet would be in an unstable orbit and that you wouldn't be able to maintain a long-term orbit around those 2 stars. Let's pull out and take a look at the whole system instead of just the star, or instead of just the planet, rather. And you'll see it's actually orbiting 2 stars. So this was the first time we found that. And we do have an, I stress, unofficial name for this kind of planet. The unofficial name for this kind of planet is a Tatooine, like in Star Wars, which I love. This was the first. We have found many more, but this was the first time we discovered a planet like that. And it was found by Kepler. Let's move on to a very different type of system, Kepler 444. Kepler 444. And this one, you look at it, it's not necessarily an particularly interesting looking system on its own. You can see the planets are clustered very close to the star. That green zone marks what we would consider the habitable zone. And you can see none of these planets are in it. So what is interesting about this system? It is very old. We believe this system is over 11 billion years old, which is old even as astronomers figure things. Just as a reminder, our solar system, our sun is about 5 billion years old. The planets are more like 4.5 billion years old. And our universe is just a little bit under 14 billion years old. So 11 billion years old is old even for astronomy. And that's how old we think this system is. It's one of the oldest known planet systems. It's not the oldest, but it's up there. So you'll notice this system looks really nothing like ours. So let's go to one that maybe looks a little bit more like ours, the Kepler 90 system. This one has some similarities to our system, some differences. You'll notice none of these planets are in its habitable zone, but there's a lot of them. There's 8. Kepler found 8 planets orbiting this system, this star. That's the same amount that we have in our own solar system. And this is the only system that we've discovered so far with that many known planets, which in some ways makes it a system very similar to our own, even though these planets probably look very different from planets in our solar system. But that's the most known planets around a single star, the Kepler 90 system. And if you want to talk about a place that's got stuff that might look a little more familiar to us, we're going to make one final stop at a system that is somewhat near and dear to my heart, the Kepler 186 system. And the reason I like this one is because this is home to one of the most potentially habitable planets we think we have found. You'll notice that one of these planets is in that green zone, Kepler 186f. This is, if you look for a list of exoplanets that we think could be potentially habitable, Kepler 186f pretty much always makes that list, and it's usually pretty high up there. We think of the planets we've discovered so far, this could be one of our best bets for a potentially habitable planet. Now, it's really hard to say because one thing we can't tell for sure yet are what the atmospheres of these planets look like. And that makes a huge difference as to whether or not the planet is actually habitable. So those are a few of Kepler's most notable discoveries, a tiny, tiny portion of its huge list of discoveries, but several of you were wondering about the next generation of planet finders. So don't worry, there is a successor to Kepler, and it's in space right now. Its name is TESS. I believe it might have been the former terrestrial planet finder. It is now called the Terrestrial Exoplanet Survey Satellite. It's only been in space for a couple of years. It's actually looking at all of space, and it's looking at the entire sky, unlike Kepler, and it's already discovered several confirmed planets with a lot more candidates. And this one is a little bit different from Kepler. It's not necessarily a true successor in the sense that it's not looking at one patch of space. What it's doing is looking at the 200,000 of the brightest stars near the sun to see if it can find exoplanets orbiting those stars, which will be easier for ground-based telescopes to follow up. And it's in space right now. It's in an elliptical orbit around the Earth, and it's underway right now. I was reading yesterday about a planet or a system it discovered where it's got 6 planets in it, and 5 of them are actually sort of in resonance with each other, which means every time the outer one orbits once, the next one in orbits twice, the next one in orbits 3 times, and so on. And that's a pattern we do see in places in our own solar system with moons. And I was reading just this morning, it found its first Tatooine, its first planet orbiting 2 stars at once. So the TESS mission is underway, and it's really sort of carrying the torch that Kepler had to drop. But it's not the only one. There's lots of planet missions from NASA and the European Space Agency, both underway in designs, in the planning works, because exoplanets are a very exciting field that a lot of people are very interested in. So we keep coming up with new ways to look for them. And I talked an awful lot, and I know we're about out of time, but Karen, are there any other questions I should answer before we end?
Yeah, there's some cool ones. We actually had a question from Becca asking, is it terrestrial or transiting?
So yes, those 2 words kind of sound similar. So a terrestrial planet refers to a...
Well, I meant for the name of TESS.
Oh, I think you're right. I think it's transiting
Okay.
Exoplanet Survey Satellite.
That's what we were wondering. So thank you for
thank you for pointing that out. I misspoke.
Other than New Zealand instead of New England, right? That was last week's.
That was last week, yeah.
So Pranav asks, are there any planet systems discovered in other galaxies? Like, can we see beyond the Milky Way to prove there are exoplanets?
Not confirmed. We've only found confirmed planets in our own galaxy. We assume that planets are just as common in other galaxies. There's a paper that claims it might have found a candidate in Andromeda, which is one of our nearest large neighbors, but it's not a confirmed planet. So we can't say for sure that we have found any planets in other solar systems yet. Or in other galaxies yet. It's
really hard to see those other galaxies. Yeah. So I can imagine. I mean, it's hard enough to see into the depths of our galaxy. Just a couple more. I know that we're like at the end of time. But Aaron asked 2 good questions. Does Kepler study the sun, and how old is Kepler? Or I should say, did Kepler study the sun?
No, Kepler never looked at the sun because our sun's actually a very, 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 very bright object, as you know. And telescopes really should only look at it if they are specially equipped to look at the sun. Otherwise, it can actually fry their instruments, that level of intense light. And Kepler was not equipped for that. As for its age, the mission was sort of in the planning stages for a very long time. It launched in 2009, and it was decommissioned in 2018. So it was in space for 9 years.
A good long life. And then just last one about sort of the look of Kepler. Why does it have yellow all over it? So what are the sort of gold colored surrounded it in that image?
Telescopes are often surrounded, so we can actually spotlight Katie's video again for a moment because she's got a shot of Kepler there. And it's telescopes are often surrounded by or covered in a reflective material. It helps reflect away heat from things like the sun. And it's also usually a certain level of shielding for things like micrometeorites because, you know, there is stuff whizzing around out there that could damage a telescope. So there's a little bit of shielding there, and it's often, you know, some thermal protection against things like the heat of the sun. And it's also those sort of bluish panels that are on the outside of the gold, those are solar panels.
Cool. Well, we are very much out of time. So I want to thank both Katie and Talia for sharing with us this journey all about exoplanets. So you guys can all give them a silent cheer and a wave goodbye, but thank you both.
Bye, everybody.
Goodbye.
And I want to thank all of you for joining us today, because we love having people to talk to about space and lots of other topics. If you want to know what else we're doing for these live streams, you can certainly check out MOS at Home on our website. There are also some really great activities and video clips that if you just want to learn more about science, not in a live stream format, you can do that at any time of day that you so choose. And if you enjoyed this program and are able to do so, we would really love your consideration of supporting what we're doing here by visiting engage.mos.org/welcome. And we'll be back again next week for another Exploring Space with another exciting topic. So I hope you guys enjoyed it, learned a few new things, and definitely enjoy the rest of your day today. Thanks, everybody.